and that will be kind of it. Okay, so from last night, let's do the usual. All right, anybody got any questions from last night? This is your turn. What you got, Sam? Let's start off.
3A.
3A?
Yeah.
Sure. Oops, wrong button. All right, 3A you said, right? All right, let's go find 3A. Okay. So as we look at 3A here, all right, what appears to be happening here is looking at what's what I'm looking for? Looking at the numbers, or not numbers, the points here, the labels. That's what it's for. Bless you. Looking at these points here, that A and A prime, as we can see, are kind of opposite, I guess, one another there. So, anybody have a thought of how we can take that solid one and somehow get it onto that dash one? Anybody have a thought of what we can do for there? Don't forget of all the transformations we looked at. But what I'm thinking here is maybe a reflection is happening to start off with. Okay, maybe if I go ahead and say reflect it along a vertical line, that will at least flip my orientation around, right? So if I flip that around a vertical line, that gets that parallelogram, then A over here in A prime, B right here at B prime. Now, where you put that line of reflection at, depending on, you might need to then just say, I got to do a translation as well. So it just kind of depends on where you put that. But the first thing I really want you to see off that one is that there's a reflection happening in there to get that orientation the same. And then wherever you would put a vertical line, like I said, there might need to have a translation happen, maybe to the left or something like that. On these, this is kind of just again generic because it says identify sequence. It's not on a coordinate grid or anything like that. So you can just at least see that there's a reflection happening in there. That's all I really care about that one. Okay. Parker, I think I saw your hand up. 7. Okay, let's get 7, guys. And as I'm flipping to 7 here, as I noticed again, number 5, A through D, we talked about those rotations real quick. What I am looking for again on 5, A through D, is just an idea. First off, one more time, positive, negative, which direction goes where, and then just kind of sketching out. Nothing fancy off of that. So before I get to that 7 there, Parker's, looking at, say, 5 there, okay? What's a negative 45 do for us one more time? Clockwise or counterclockwise? Negative 45. I'm sorry? Clockwise, correct. Negative 45 takes me clockwise. Now, 45 degrees, all right, puts B prime-ish there and A prime-ish there, okay? But what I wanted to really get and see out of you guys, you know, it's clockwise. So where should that at least be? It should be kind of above that original one, okay? All right, so now let's finally drop it down to number 7 there. And 7 kind of goes along with what 3A was off there. First thing I'm the same thing as noticing is that his orientation's been flipped. So that's the first thing I'm gonna do is do a line of reflection there. So, you know, that line of reflection again, wherever you want to draw it in, if you want to draw it in, you got to do reflection. Now it's not yet on the dash one yet, so maybe a translation also needs to happen as well. Moving it, say, vertical for that translation. That's a possibility. It also looks like, and taking your patty paper would be maybe helpful, but I think if you also did a reflection right there, I think that would also appears to land on itself. So it looks like also maybe take care of that and just a reflection, a single reflection with that. Sam?
Could you just put, like, let's say, at the origin, like, by point C there, and then just rotate it?
And there's also rotation hiding in there too. Correct. Yeah. So I guess that one really could be a combination of things. A single rotation works, single reflection, translation. Again, don't kill yourself on those. You should be fine. All right. Other questions? Anybody, Scott? This is getting your time.
9B.
9. Sure. Let's take a look at 9. Okay. Taking that, this is a cubic function. We've seen a cubic a couple times. Now on that one, this is first off where I'm going with my patty paper. Okay. Now on my patty paper, as I put that on top of there, my patty paper, I'm putting two things on there as always. My pre-image, so the cubic function there, bless you, especially C and E I'm putting on there. And then where do I put that little kind of mini XY axis to keep track of our turns? Is it going at the origin? No. What do I want to rotate it about? The point 1, 1. Bless you again. So on my patty paper, I have two things on there. I've got the pre-image, but then I got to put that mini XY axis so we can keep track of returns. It doesn't say to rotate on the origin. This one says to rotate at 1, 1. So I put it at 1, 1. Then I take my patty paper and I turn it 180 degrees. How many turns of the patty paper off of that? 2. Doesn't matter which way. It says clockwise, but does it really matter for 180? No. So but clockwise, 1 turn, 2 turns, and that C and E, I believe C should stay in the same location, and then E should pop into where? -3, -3, I think. Sorry, that's at the origin. What's that? I was gonna say about to bring that back, yeah, because that was at the origin. So yeah, bring that back. I think it should be at yes, -1, -1 then off of there. Okay. So take your pad paper, put the pencil underneath it, and trace it back over. But make sure you please pay attention. If it says the origin, cool. Put the mini XY axis there at the origin. If it doesn't say it and it says 1, 1, then make sure that mini XY axis goes there and you turn it on that 1, 1 thing. Anything else? Anybody else? Oh, me. My bad. I wasn't paying attention all there. I saw 8 and my bad there, Sam. All right, let's try this again. Number 9, and then I'll go back to those hands there. My bad. Number 9. The translation moves the given pre-image, so we got ourselves a parabola down here. Excuse me. Moves the given pre-image up 3 units, and then reflects it over the line y equals -1. Then find me the points of C prime, E prime, F prime. So usually when we ask that type of question, we have two things happening, right? A translation and then a reflection. What we're usually looking for then is the coordinates of that final image. So first thing is I'm going to take what? Move it up 3. So I'm going to take C and move it up 1, 2, 3. E goes 1, 2, 3. And F is 1, 2, and 3. Okay? Then what we're going to do is reflect it over the line y equals -1. Again, get into your heads. What does y equals -1 look like? That is a vertical or it's a horizontal. Now we're going to reflect those points over that horizontal line. So we've got C moved up to right here. This is 1 unit away, so 1 unit away. And then 1, 2, 3, 1, 2, 3. That's F prime, and then E prime is on the other side. So I'm looking for that parabola right there. Then, as it does state, find the coordinates of that. Reflection over the line blank would reflect both parabolas onto themselves. This is the parabola's axis symmetry. So we're going to talk about that more second semester, the axis symmetry, in the algebra part of things. So when it says what line is out there that reflects it onto itself, how could I get this thing to reflect onto itself? Where's that sweet spot in the middle? Right here, and it does it for both parabolas, doesn't it? This one down here reflects onto itself by doing this vertical line of reflection. And that is located at x equals 2. That gets a special name in algebra. That's our axis symmetry. I might have briefly mentioned it once or twice. Second semester as we keep our backflow going of algebra. We'll talk about that again. My sophomores, I know we've talked about that last year. All right, haven't done much with the geometry right now. Okay. All right, Andrew, I think I saw a hand up. What you got, Andrew?
He is 13.
13? Sure, let's go find 13, guys. Oh, okay. Number 13, very similar. I think you might have talked about one similar to this yesterday. It's a good SAT question. A little bit different here. Go sketch that out. 0, -5. So 0, -5. It joins it with the origin. So we're at the origin. We got a point there, and 0, -5 puts me right there. That's the segment we're referring to. Now, again, as we keep reading that problem, we're talking about slope. And as we worked all the school year, vertical lines have a slope that is undefined. Now, after rotation of negative 90 degrees about the origin, which direction is that going to take me, clockwise or counterclockwise? Yep, negative 90 is going to take me clockwise, so 90 degrees puts me, right there. So we're at 0, negative 5 here, and over here we're at what? Negative 5, comma, 0. And what is the slope of that then new segment? Verticals are undefined and horizontals are 0. Yep. Okay. All right, good question there. Anything else? I think so. Another hand up. Yeah. 11. Okay. So if we do more than one transformation, we call that a composition. So just a composition is all I'm looking for. In math, we do more than one transformation. We call that a composition. Anything else on anything? This is your call. All good questions here, leading up to Friday's quiz. Okay. The usual. Make sure your name's on it, throw in the basket. If it's not fully completed, turn it in tomorrow. Okay, but if it's ready to go, throw in the basket. And today, I'll pass out the notes. Actually, you don't need padding paper really today. A few times we don't need it. So I'll get out these notes here in just a second for you.
I was gonna say, you gotta run right now.
Alright, I'm gonna pass out a supplement to our notes, so if you don't think you stuff into your book and left pride, we'll rush off that. Here it comes, sir. Is there enough there or do you want more?
Nope. I mean, no, not enough yet. You need one.
Sorry, there. We're just gonna do this page right here. Okay, so let's take a look real quick as we walk through this. As you can see on that front side, we talked a lot about that yesterday already with symmetry. Let's do the back side where I really want to hit you out today with the polygon work. So let's run through that front side here. A figure has symmetry. If there is an isometry that maps onto itself. So a figure has symmetry if we can do that reflectional or that rotational symmetry that we talked about. If we can do that, we say a figure has symmetry. So as we talked yesterday, we have two types out there, right? Reflectional and rotational. And I'm pretty sure you can figure out for the two definitions there which one is what. Reflectional, symmetry, and rotational. Now yesterday as we started off with things, we didn't say anything about a definition of rotational symmetry, but then we looked at our book. The book defines it as 360 or more than 0 and less than 360. Depending on what book you use, one of our older ones that we used to use, they defined it as 180 or less than. So it says the same thing really. Okay, so if you have rotational symmetry, it's between 0 and 180. Okay. Now, as we look at these figures then, all right, we've hit that isosceles trapezoid and the letters left and right. All right, so I'm not going to worry about that. But think about another letter that's not up there that has reflectional symmetry. It's another letter that has reflectional symmetry. Eric? B. What type of symmetry does that have? Horizontal. Now, depending obviously how you make that B, my B, not so much, right? But if we were to do a type print off that with the fonts, as he said, a B is going to have reflectional symmetry. Okay? Is there just the one out there? ecno, D, C, right? So on and so on. What's that? Oh, okay. Rotational.
C.
Z's guy, we saw Z yesterday. Z is the weird one. S is also the weird one. And N. N is the other kind of weird one that students sometimes don't process well, I guess, maybe. But Z does have reflectional symmetry out there. We talked about H. H is the one that has what? H had both of them, right? Reflectional and rotational. Okay, we hit that a lot yesterday. I'm not going to spend our time there. I want to really spend our time on the back side of things. So let's keep talking here. Okay, we got some shapes going on here. Let's talk about these though. First thing is, does it have reflectional symmetry on that first one, letter A? We do have reflectional symmetry. Where is it happening at? Draw them in if we have those reflectionals. Vertically, right? Horizontally? And do we have the diagonals happening?
Yes.
Okay. And as we said yesterday, I say didn't need patty paper, but if you're not sure about some of those diagonals, fold it along that diagonal you think might be working. If it does, great. If it doesn't, well, it doesn't have reflectional symmetry there. Okay. Now, does that thing have rotational symmetry? Yeah. So when we say what's rotational, and the angle of rotation, I want the least degree possible. So if you can mentally erase those lines of symmetry, and what would be the angle of rotation here? What would be the angle of rotation? A 45? I think it's got to be 90. So a 45 is, I think it's got to be 45, or sorry, 90. Because a 45 is going to put it on its side like that, okay? A full 90 does rotate that correctly. So the angle of rotation on this one is, yeah, it's 90 degrees then. Again, if you're not 100% sure, we've got patty paper. Patty paper can kind of sometimes help you out with that. 90 we can usually clearly kind of see. All right. What about the next one? What about that one? Do we have reflectional in there?
Yes.
Which types? Horizontal, vertical. And this is another one that students sometimes will get freaked out by, thinking that there's a diagonal in there. Now you can try to throw a diagonal, but if you maybe get your patty paper out and try to do that, it's not going to happen. Okay, there is not going to be a diagonal in there for that one. Okay, so the best we got is horizontal and vertical. How about rotational symmetry? Do we have rotational in there?
Yes.
Yes. What's the degree again?
180.
Now this one here, a 90 is not going to happen. Okay, a 90 gets it vertical, so we got to do a 180. And a 180 then is fine. It just can't be a 360. Okay, so 180 or less gets you gets you rotational symmetry. Okay. All right, let's keep going on here. Let's flip it. Let's take a look on the back side now. All right, this is where we want to be. All right, this is a little bit of a warm up on the other side. Now we've already briefly talked about these over the last couple days. So the polygons that we were looking at right there, we said a hexagon, we said a pentagon, but these are actually all what we call regular polygons. As you look at all these that I have on this side here, these are all regular polygons. So a regular polygon has a center, it has equal sides, and it also has equal angles. So all the sides, all the angles are equal. What we say is it's equilateral and also equal angular. Regulars are really where we will focus on things. We can draw a hexagon with 6 sides, but does it turn out to be like that? No. You know, we could draw a hexagon 1, 2, 3, 4, 5, 6. I wasn't pretending for it to be good. Okay, 1, 2, 3, 4, 5. It's a hexagon, not a stellar hexagon, as I was pointed out there, but it's still a hexagon. What we really focusing on is the nice and pretty ones, not mine. The regular hexagons, the regular, what's this one here? Octagon. Those are usually what we are going to focus on throughout this school year. So it's still a hexagon, it's just that we focus on the nice and pretty ones. Okay, that's the wrong button. All right. So on there, okay, we were talking about the last couple days. It can be divided into uh, congruent and another type of triangle. All those triangles are congruent. As we slice it up, all those triangles are congruent. But there's also something else true about these triangles. So if I look at this hexagon here at that center, as we cut that up, what is true about the type of triangles that are being created? You're close there, Sam. Yeah, there's only one type out there. He said the first thing he said was equilateral. There's only one polygon out there that you create equilaterals. But what is true for every one of them out there is that these are all going to be correct, isosceles triangles. Because think about it, it's from the center to that vertex. So those are all equidistant there. For a hexagon down to an octagon right here, we don't know, well, we haven't talked about it yet, but we'll talk about that down the road. In a hexagon, actually we get this going on. All those sides, all those lengths are turning out to be equal, but that's not true in any other polygon. It's just the hexagon that one happens. And like I said, second semester, we will talk more about that when we get into some trigonometry as well, but we're just not there yet. So, what do we just say? All congruent, and they're also going to be isosceles. All right, first thing we had to do is figure out what is that single degree of rotation. What is the smallest degree of rotation for a hexagon, for a pentagon, for an octagon? For a hexagon? So we talked about that yesterday, right around that center there, there's 360 degrees. And to calculate that single turn, it is always 360 divided by however many sides. Creates that how many triangles. So as you corrected yourself, a single turn is what we want, 60 degrees. You keep that in mind. Now let's just kind of spin the wheel here, okay? So take that first one, letter A. Name the image of B for 240 degree rotation about M. How many turns of that is it going to be? 4 turns, 1 turn 60, 240. Follow-up question is, which direction are you going? Default is counterclockwise. If they don't tell you, plus it's a positive, right? So we're starting at B, 60, 120, 180, and 240. So B lands on, that's all I'm looking for, okay? You just got to know how many turns and then which direction you go. What's the next one say? 60 degrees, but then they follow up by saying clockwise. Now there's a typo here. It says about, this should be the origin, should be about M. That's a typo. So anyway, 60 degrees, taking F, 6 degrees clockwise. Where's F? Clockwise, make sure you go the right direction. So where's that going to land, E or A? That's all I need from you, okay? We can take a single point, we can take a segment. So go find segment CD. Where's CD at? Right here. And which direction we want to go? Counterclockwise 180. So 1, 2, and 3 turns. So it lands on, yep, FA. Okay? That's all we need from you. It's all about that center to start off with. We call that a central angle. We want to know what that central angle is. When we come back in January, we're going to talk more about central angles and angles in a circle. This is all kind of pieced together. Okay, down there on that octagon. Your first thing you got to figure out is what's a single turn on an octagon? 360 divided by, yep. So single turn is what? 45, yep, 45 degrees. Once you know it's 45 degrees, make sure you just go the right direction. 135. So how many turns is a 135? It should be 3 turns, right? 45, 90, and then 135, right? So rotation of A, find A, which direction we go in? 1, 2, and somebody got F? Take DE, go find DE, that's that side. 270, so 270 is how many turns off of that one? Yeah, a 135 was 3 turns, 270 is going to be another 3, right? So DE, which way are we going? Clockwise. So counterclockwise. 1, 2, 3, 4, 5, 6. I'm here in BC or CB, however you want to say it. But that's what I was hearing. Hopefully we're in agreement there. And then 135 counterclockwise. B. Where's B? Counterclockwise. 1, 2, and somebody got G? That's it. Okay. So it's all about finding that what we again call a central angle. That's the least amount of turns off there. Okay, before I go down to the last group here, one of the polygons you run into, let's just quickly see if you remember your names and sides with the polygons. So for a number of sides and then the name of the polygon, all right, because what we're going to find out here is some of you don't know the names and the sides together. And there's one that happens quite a bit. You've never probably learned, but I'm going to throw it out here at the same time. Okay, number of sides. What type of polygon is that? Angle. Don't overthink it there, Kate. Okay? I'm not trying to be an ass up here, but it's just a triangle. Okay? A four-sided one. Now, quadrilateral is general. We want a specific one here where we're talking all about all the same sides and all the same angles. And the special one of that is the square off of that. So yes, quadrilateral does work in general. So you're not wrong off of that at all. But as we work more with the regular side of things, a regular triangle, a regular hexagon, just keep in mind the regular quadrilateral, yes, it is a square. Okay? Four sides, yeah, it's quadrilateral. The ones that we usually focus on is the square. Okay, five sides is a pentagon. Penta is 5. 6 sides is a hexagon. Okay, come up to the first one here that it's not a lot of people usually know that one. 7. Okay, there's 2 words out there for it. I heard the first one. Septagon. Or there's another one out there for it too. Because it does get used interchangeably. Okay. So the other one is heptagon. Either one is fine. You'll come across either one. Heptagon and septagon both are the 7-sided figure. 8 sides we know is a octagon. Okay, here comes the next one that's not always known. 9. Nonagon. There we go. Yeah, if you didn't know it, that's fine. But it is a nonagon. Usually up through 10 is what we need to know, plus 1 more. So 10. Yeah, I'd say go maybe use your biology or your metric off that. Decagon. Decade is 10, right? Decagon, decimeter. Okay, 10. Those are the ones you should absolutely know. Okay. Now the one that pops up quite a bit because it does divide nicely with 360, that does pop up, is a 12gon. It does get a special name that again happens quite a bit. So after 10, we usually just say, for like 11, we just say 11gon, 13gon, 20gon, 50gon, and so on. Do they have special names? Yeah, who cares? But the one that we really run into the most is a 12-sided one, and we call that a dodecagon. 12 pops up quite a bit because 360 divided by 12 works out nicely. Okay, but a dodecagon is a 12-sided polygon. So it happens quite a bit. I just want to throw that last one out there. Those are the names that you need to be aware of. We're not going to throw anything else out there. If I say anything else, like I was saying, it's going to be 15-sided figure. I know it's got a special name out there. I don't care. We will just call those like a 15gon like that. Okay, make it easy. Very similar to what we did with the polynomial work. Okay, like a 5-term polynomial. I'm sure there's a special name out there for it. Don't care. We say it's a 5-term polynomial. Okay, so we digress there. Let's finish this off with number 7 then. Check all that apply. Okay, so we have regular figures right here. And all these regular figures, we're taking a look to first see is there reflection happening there, reflectional symmetry. And then after that, what I want you to do is kind of erase in your head that line of reflection, and then go through and check out to see what type of rotational symmetry is happening in there as well. Okay, so I'm going to put a quick minute on my clock there. Just check it all that apply. Figure 1, can you check any of those? Figure 2, can you check any of those? And then figure 3, can you check any of those? All right. Like I said, I'm gonna give you a minute, and then we'll come back real really quick and talk. And I think that'll be about it for the day. Drag it across. Yes or no? Can you put check there or not? Annoying one. Let's do it real quick. Let's see if any of these have refractional symmetry there on that line that's happening. So figure 1, yes or no?
Yes.
That one, yes or no?
Yes.
And then on what is that shape? An octagon?
Yes.
So do we have it?
Yes.
Good. Now, after that, figuring out the rotational symmetry here, the clockwise or whatnot. First, again, before you do anything, go through each figure and just figure out what's a turn on that. What's the least turn for that? So it's a square. Ignore the line there. On that square, what's its rotational symmetry?
90.
It's 90 degrees, right? 360 divided by 4. You know, if we were to do that same thing we were doing, we get the same 4 isosceles triangles in there. And 360 divided by 4 is a 90-degree turn. On the triangle, again, imagine you could erase out that vertical line. What's the turn on this triangle here? 360 divided by? Always 3.
120.
Yep. This has a turn of 120 degrees. A little bit of Deathly Hallows symbol going on there. Okay. And then lastly for the what? Octagon. We talked about a second ago. Yep. And at some point you'll know those, but if you don't remember, it's always 360 by how many sides. That gives you those congruent triangles in the middle there. Now we know that. Run it across. Figure 1. Does a 45 then work?
No.
No. It has to be 90 or greater than, right?
Yeah.
Multiples of 90. 45 is not working.
Nope.
Does a 60?
Nope. Yeah.
Does a,
No. I mean, no. Yeah.
come on.
I was trying to get.
You don't know what a triangle is, so you know.
Yeah, I know.
All right. So let's try this again. 60 is a no.
No.
90 degrees.
Yeah.
Does it matter which direction? 120,
No.
180.
Yes.
That's all we should have checked then. Okay, figure 2 says a 120. Does a 45 work? Does a 60 work?
No.
Does a 90 work? Does a 120 work?
Yes.
Does a 180 work?
No.
It's got to be multiples of 120. Always have somebody say 60 in there. It doesn't work like that. And last one we said what? 45? 45 work?
Yes.
60 work?
No.
Correct. 90 work?
Yes.
120 work?
Yes.
That's a no. And then a 180?
Oh, I didn't have that check.
Okay. 180 finishes off, right?
Okay.
We're good here. Okay. So get those turns and then go from there. All right. That wraps it. As I said, that wraps up our topic. So Friday will be our quiz, our last quiz. Tomorrow when we come in, we're going to do 2 things. We'll go over any questions that you got from the quiz review I'm about to pass out to you. And I'll pass out your first quiz, talking about it. First quiz was fine. I'm not worried about that. But quiz 2, we'll have a little bit on there, but it's primarily going to focus on rotations and symmetry. Okay? And then next week, when you leave me on Friday, I'm gonna give you the quiz review for the algebra quiz next week. It will be heavy on polynomials and equations. It will be short enough to where it better be done in the time that's allotted for the early dismissal time. It should not take you anything more than that. It's taking a full class period. I'm not trying to be whatever for anybody. As Mr. Muni, the other geometry teacher, and I were talking this morning, we are looking at schedules for next year already. January, February is where that happens with you. This quiz right here, and then right here on December 13th, we are going to take an algebra half test. It's going to be a culminating half test over everything that we've done algebra-wise this year. Between this quiz and then on that December the 13th, that algebra test, this will give me and also you a good idea of, should I take Algebra 2 or take Algebra 2 Honors next year? Is it going to be the final nail in the coffin? No. But that should give you an idea of like, hey, I'm ready to go, or hey, I need to back that up, okay? So those things right now are what I'm going to start using to kind of help you out. Where should you sign up to be successful out for next year, okay? And then when we come back in January, we'll continue on with our geometry notes and go from there, okay? So that's our plan. Let me get the quiz review out for you. Time is, like I said, keeps on ticking out. This morning I tried to catch a few of you as you're walking in. I ran Matthew through Unit 8. Most of you are really good. You're good to go. You're fine. There's a few of you on Matthew that need to get going. That's pretty much as simple as we can say it. You need to get going on Matthew through Unit 8. Tomorrow we'll be opening up the last one there, Unit 9. Okay? So you need to make sure you're doing the right stuff off of there. Okay? All right, quiz review's coming out. We got some time here actually today, about 10 minutes. Yep, don't pass it back. Papers come around, just few pages here. Okay, this is your quiz preparation. Yes, sir. What is this? Second notice? Nope, that's on you.
I want to relive the games.
Get your keys online. Alright, as always, if you think hopefully it's right, if you think something's wrong, call me out on it. We'll go over these questions tomorrow, and have that as well. We'll be Matthew in time for you. What do you want?